Hey, I hope you're having a good weekend. We're going to dig right into this problem here. We're going to solve this three linear equations with three variables, three unknowns, using substitution. So, first step we're going to do, number one, is we need to solve for a variable. Okay? Now, we have a couple of them already solved for a variable. So, I'm going to go ahead and just pick the first one here. So since this is solved for x, we're going to go ahead and take this expression here and plug it in for x into this equation right here. Notice there's no x in this one. So let's do that. We solve for it, and then step 2, plug into another equation for that variable, whatever variable we solve for. In this case, it's x. Okay, so let's plug it in. So we're going to have going in for x. Okay. So now we have an equation with two unknowns. And what our goal here is to get all of the variables the same. So right now we have z and y. So before we get to the next step, let's go ahead and simplify this so it doesn't get to be too large. Okay, so we're going to distribute. And remember, simplifying, we distribute, and then we combine like terms. So we're going to combine what we can. So we're going to have 17y. Nothing to combine there. Combine the constants. Okay, so now we just need to fill in the y in terms of z. So right now we look at this last equation. We haven't used it yet. We have a y and a z. So we want to solve this equation for y. So we're going to use the third equation, remaining equation, and solve for the variable that we need. I hope you're listening to the video, because if you just write this down, you wouldn't understand what I mean. So the one that we need is y. So we're going to solve this for y. So let's take this equation down here and let's solve it for y. So we can substitute it in here. All right. So solving this equation for y, moving the z to the other side. Okay, and canceling out the 3. Okay, don't panic. Yes, they're fractions. That's all. Parts of numbers. Fractions are numbers too, okay? So we're going to take this quantity right here, which represents y, and we're going to substitute that in for y in our condensed equation. So, plugging it in. And then don't forget the rest of the equation. Now look at there. This is the goal, guys. The goal is to get an equation that you can solve where all the variables are the same. And then we're going to solve this equation for z. So we're going to start off by distributing. And remember, when simplifying, we always distribute first, then we combine like terms. So combining our two z's. If we combine these two z's, then we have to cancel it out. So this minus this. And then we take that answer and we cancel it and move it over to this side because we have a z over here as well. So what we're going to end up with, again, let me repeat that. We combine these two in our calculator. This minus this. And then we have to cancel it out so that we can get rid of it. Now, one of the ways you could do it, you could combine these, or if you want to just cancel them out individually, you could just add 3/4. You could just add 34/3 z on both sides to cancel that out. And then you could add 12z on both sides to cancel that out. So what you're going to end up with, once you cancel these two out, or if you combine them and then cancel them out, it's up to you. Once you do that, you're going to end up with that on the left-hand side. Okay, combining these two together, we're going to get that. Okay, and then we can cancel out 73/3 by multiplying by the reciprocal. And then basically the 3's cancel. 292 divided by 3 is equal to 4, believe it or not. Nice, pretty number. Okay, now that we've done the difficult part. So here, and we're solving, and we just solved it. Okay, now we take that answer and plug it back, take solution, and put into another equation to find another variable answer. So we're going to take that solution, we're going to put it into, let's see, z, so let's put it right here. And then that way, if we plug it in here, we can find y. So we will have 3y plus 2 times 4 equals 14. Solve this equation for y, and we get 2. Now that we have z and we have y, we're going to take both of those and we're going to plug it back into the first equation and solve for x. So x equals 3, y is 2, minus 3 times z is 4, plus 8, and x equals 2. So now we have solved for x, y, and z. The way you write your answer, the point of intersection for these three lines, x goes first, y goes second, z goes third. And so it's going to be 2, 2, 4. And that is the point of intersection of those three lines. We have three axes here. X-axis, y-axis, and z, which is our third dimension axis. And there you have it. So please make sure you go over this and over this and over this and over this. Study it and study it and study it. And that's the only way, unless you're a genius, that you're going to understand how to do this. And come to class on Monday with your questions. Hope you're having a great weekend. Well, at least until now, right? Just kidding. See you on Monday.